Hello everyone, my name is Yulin Feng. I'm from School of Civil Engineering and Architecture, East China Jiaotong University. Now, let me introduce myself. I will introduce myself in two parts. Part one is individual introduction. Part two is research introduction. So, first one, individual introduction. I'm a PhD, postdoctoral, outstanding young scholar of East China Jiaotong University, and the Dean of Teaching Research Section of Structural Engineering. I'm engaged in rail transit infrastructure, safety service, and intelligent operation and maintenance research. The education. I'm graduate from the Southwest University for nationality for the bachelor degree at 2013, and I'm graduate from Lanzhou University of Technology for master degree from 2016, and graduated from Central South University for my PhD from 2019, and work experience from 2020 to present. I am the outstanding younger scholar of East China Jiaotong University, and from 2022 to present, I'm the postdoctor of Central South University. The academic achievements papers. Now I have published 60, 63 papers, including 43 ICI, 20 Chinese journal papers, include 11 Chinese EI journal papers, and I have authored 10 patents for inventions and 8 patents for utility models. I have also authored editor-in-chief published one monograph on seismic resistance of high-speed railway bridging. And the next part, contribution. So I have gained the first prize of science and the technical progress of Minister of Education once. Excellent doctoral dissertation of Hunan province, and also the excellent doctoral dissertation of Central South University. 2022 Railway Major Scientific and Technology Invention Achievement. The East China International Internet College Student Invention and Entrepreneurship Competition Gold Award instructor. And also the 7th Jiangxi Province Internet University Students Invention and Entrepreneurship Competition Silver Award instructor. And also 2021 National Structure Engineering Academic Conference experience paper provides. As a co-member of the innovation team in national key field of service performance monitoring and guarantee or protect of wire bridge and tunnel structure. My research has been supported by the National Natural Science Foundation of China and other province foundation. For example, National Natural Science Foundation of China, the Fellowship of China Postdoctoral Science Foundation, the State K Laboratory of Performance Monitoring and Protecting of Rail Transit Infrastructure Foundation, Jiangxi Province Natural Science Foundation, Hunan Province Natural Science Foundation, and National Engineering Research Center of High-Speed Railway Construction Technology, and also the Education Foundation of Jiangxi Province. To promote research in the field of mentioned above, I also have served as a communication reviewer for the National Natural Science Foundation of China, an expert in the evaluation of science and technology award in Jiangxi Province, a younger edit for the Journal of Earthquake Engineering and Resilience, editor for the Journal of East China Jiaotong University, a young editor for the Journal of Disaster Prevention and Mitigation in Engineering, editor for the Western Quality Education, and also a member of Architectural Society of China. So that's how it's my individual introduction. The second part is the research introduction. So I will talk about the research content for recent years. So the title of this research introduction is Quantitative Description of Seismic Induced Damage of High-Speed Railway Bridge Rail System. So, research significance. The operating meaning of high-speed railway in China has exceeded 40,000 kilometers, and the corruption of bridge is more than 50%. Almost all of the built and under construction high-speed railway networks are in earthquake zone. So at the left, security channel, China's high-speed railway is under the earthquake threat. So research needed. So last year in China has many earthquakes had happened had happened. For example, Qinghai, Wenyuan, Sichuan, Luding, and so on. So these three pictures we can see the bridge, the track, or the rail, or the tunnel. Both of these key members on the high-speed railway line are damaged under the earthquake. earthquake. This picture also shows the earthquake damage under the earthquake. So, scientific problem from the earthquake damage on the from PPT, you can see there are some scientific problem to calculate it or need to solve. First one is mapping relationship. Mapping relationship between damage degree of key components and the check in irregularity under earthquake. It is the link between the degree of seismic induced damage of the check bridge system and the safety of driving on the bridge. So we can see, we can think how to review the damage mechanism and energy deception mechanism of key components. So we can see the bearing, the pier, the track, the fasten, the CA motor. Both of these components we can call the key components in the high-speed railway system. High-speed railway system. So next slide, how to consider the multiple randomness of earthquake and the structural parameters. Next one is the corresponding relationship between the traffic safety on the bridge of the track bridge system and the seismic damage limit of the components. Seismic design of components of control track bridge system. You can see how to determine the limit state of driving safety on bridge after earthquake damage. How to evaluate the applicability of driving on bridge with earthquake damage. So it lays a foundation for research and the development of seismic design and isolation technical based on driving safety. Now let's take the types of the ballast track slab. So in China, we also use these three types track slab. We call type 2 longitude track slab. Type 1 and 3 unit track slab. It means type 1 and type 3. It's composed of unit track slab. So open one unit, the length of one unit track slab is 5.6 to 6.5. And in this track slab, it has many key components. For example, wheel, CA motor, steel bar, and the base slab, the track slab, and so on. So let's say these key components will have the damage under the earthquake. We can say this this picture shows how many damage will occur under earthquake. For example, this one motor void. This one fasten fasten brake, and this one is the bearing brake. This one is the pier settlement, and so on. So all these damage, seismic damage, will be upload from the bridge, the track, until upload on this real surface. It will cause the real surface become irregular. So we can say we want to find a method to describe the damage on the surface of the rail. So we built the method for different type track slab. So this one is the bridge deformation, or we can say this one is the pier settlement. The pier have a settlement length. We will take these two beam have the deformation. So when we calculated the deformation of the bridge, so we should build a method to describe the dispersion upload on the real surface. So this is the method. So this one is the stiffness of any interface. So if we say the fasten, if the fasten is break, we can say this one is equal 0, and if the a motor is break, we can say this one is also 0, and if it's not break or break in different degree, so we can say KCI equal KC. So KC is the different damage stiffness. Let we calculated the method. Calculate the method. So when we calculated, we should verify that the method. So we use four examples for verify this method. The former PPT will verify the one types check slab. So this one verified the second the second check slide. So we can see we use the experiment result and the FE model result to calculate the method that we propose. So we can see the tangents is okay. Tangents is okay. And we also use the date from the field method date. We can say we measured 14 nearly 14 pairs and this is the definition of the real. So that the black line is our method result, and the red line is the field method date. You can see in two result is in is the same. It's the same. So you can see our method is correct. And we also use the earthquake deformation for verification. So we can see also get the same result. So when we verify the deformation in different situations, so we also need to variation in the method in the train track bridge couple system, large system. So we can see we put the deformation that's calculated from our method, and also put the failed method date. We can get the dynamic we could get the dynamic result from the train. So you can see also the same. So when we calculated our method, we can use the method for calculating or for describe of the seismic damage of the high-speed railway system. So that's all. Thank you.